Okay, so today's lesson is about absolute value functions, and I'm going to email this out to you guys so you can watch it. Remember, there's no required class connect today at 1:30 unless you have been specifically invited. So this lesson is being recorded and I am sending it out. Here's our week this week. So today we are doing absolute value functions. You do have a quiz today, so make sure you take the quiz. Tomorrow we're going to do our Unit 4 review. That's due, and then we're also going to have our Part 1 review at 12:30. And then on Wednesday is when you're going to take your Unit 4 test, and then there's an optional class connect going over Part 2 of the test on Wednesday, and then on Thursday we'll start Unit 5. And then just a reminder that Unit 3 test deadline is this Friday. Okay, so make sure you turn in that Unit 3 test before this Friday. All right, here's a review of our transformations that we learned last week. So if I want to shift something up or down, I'm going to add a number or subtract a number outside of the parentheses of that function. That's your big clue for vertical. So these two are vertical. Okay. If I want to shift something left or right, I'm going to add or subtract something inside the parentheses. So these are horizontal. Okay. And then reflecting, we're not going to get too much into reflecting, but we are going to talk about dilations and vertical shrinking and stretching, so compressing and stretching. If I multiply a function outside of the parentheses, that's a vertical stretch or compression. If I multiply something inside the parentheses, that's a horizontal stretch or compression. Okay, so just a reminder of what we learned last week. Okay, so here's a warm-up. Let's just do it together. Describe the transformation of the graph of f of x to the graph of g of x if, so if I add something inside the parentheses, that's a horizontal shift left 2 units. Okay, because it's plus 2. If I multiply a function by 2, like in b, that's a vertical stretch by a factor of 2. Okay, whatever that number is. If I multiply something inside the parentheses, that's a horizontal compression. Okay, remember, horizontal is always opposite what it seems like. So if it's a whole number or a number bigger than 1, it's a compression. And then to find the factor, we just take the reciprocal. So the reciprocal of 2 is 1/2. That's a review from last week. So if you don't remember, make sure you go watch the recording from last week. And then this guy here, if I just add 2, that's a vertical shift up 2 units. Okay, so that's just a reminder of what we did last week. All right. So here's our learning target for today. I can graph and describe transformations of an absolute value function given the equation. So I only have 15 minutes. Let's see if we can get through this in 15 minutes. So absolute value graph. So what are some points that would be on the graph of f of x equals the absolute value of x? Well, first things first, absolute value is always positive. Okay, so make sure you remember that it's always positive. So if I wanted to plug in -3, the absolute value of -3 would be 3, right? If I wanted to plug in -2, the absolute value of -2 would be +2. Same thing with -1. Absolute value of 0 is still 0. Now what if I wanted to do 1, 2, and 3? The absolute value of 1 is not -1, okay? It's always positive, so 1 would be 1, 2 would be 2, and 3 would be 3. Okay, absolute value is always positive. So let's go ahead and graph these. So -3, 3, -2, 2, -1, 1, 0, and then 1, 1, 2, 2, 3, 3. What's cool about this is you can plug in whatever number you want. Any number. I can plug in a number and get the absolute value. So we're going to connect these with a line. If I can draw a straight line. I can't, but you know. So all of these, imagine those are connected with a straight line. This hand's really bad at drawing lines, okay? That's what an absolute value graph looks like. It's a V, okay? It makes a V shape. So an absolute value function is a function whose rule contains an absolute value expression, just like we did. The parent function for the absolute value function is f of x equals absolute value of x, and that's what this graph looks like. If you notice with these lines, these each have a slope of 1 because it goes up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. This has a slope of 1. This one has a slope of negative 1 because it goes down 1 over 1, down 1 over 1, down 1 over 1. So that's really important to remember. And then the point where they meet is called the vertex. So let's look at these graphs again. There are really two ways to to graph an absolute value function. Number one, you can create a table of values and plot the points, or use your knowledge of the parent functions and transformations to plot the graph. Okay, so let's do number one. So creating a table of values and plotting the points. So we're going to plot this function f of x equals x minus 2 plus 4. So basically we're going to start with negative 1 and plug in negative 1 for x. So negative 1 minus 2 is negative 3, but the absolute value of negative 3 is a positive 3 plus 4 is 7. So negative 1, 7. 7 is right there. Okay. If I plug in 0, 0 minus 2 is 0 minus 2 is negative 2. The absolute value of negative 2 is positive 2. Positive 2 plus 4 is 6. So I get 0, 6. If I plug in 1, 1 minus 2 is negative 1. The absolute value of negative 1 is positive 1 plus 4 is 5. 2. 2 minus 2 is 0. The absolute value of 0 is 0. 0 plus 4 is 4. So I get 2, 4. All right. 3. 3 minus 2 is 1. The absolute value of 1 is still 1. 1 plus 4 is 5. So 3, 5. Now we're going up. Okay. 4. 4 minus 2 is 2. The absolute value of 2 is still 2. 2 plus 4 is 6. So 4, 6. And then 5, same story. I get 5, 7. So there's my dots, and I can connect them with a straight line. At least I can try to connect them with a straight line. And there's our graph. I want to show you something. The vertex is right here. Okay. The vertex is at 2, 4. Okay. These numbers right here have a direct link to those numbers right there, and we're going to talk about that in a second. So we can also graph them by transformations. Okay, so if I start with my basic absolute value function, my vertex is always at 0, and my lines have a slope of positive 1 and negative 1. Okay, that's our basic parent function. If I wanted to shift it up 1, I would add 1, and it would just, every point on there would go up, 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 up. Okay, if I wanted to move it down 1, I would subtract it by 1, and every point would move down 1, over and over and over again. Okay, if I wanted to move it left or right, if I wanted to move it left, I would add 1 on the inside, and every point on there would go left. Okay, that one, they would all go to the left. If I wanted to make it go right, I would subtract 1, and every point along that graph would move to the right 1. Okay, if you notice, they're inside the absolute value symbol. Okay, so there's not really parentheses, but there's inside the absolute value symbol, and then for vertical, they're outside the absolute value symbol. If I wanted to vertically stretch or shrink this graph, vertically stretch, I'm going to multiply it on the outside. So if I wanted to vertically stretch it, I would multiply it by 2. 2 times the function, so it would be 2 times the absolute value of x, and that graph would become skinnier. It would go up away from the x-axis. If I wanted to make that graph flatter, I would multiply the whole thing by 0.5, so it'd be 0.5 times the absolute value of x. What happens is that becomes flatter and it goes towards the x-axis. This is just a review of last week. So here's the general form that makes it really easy to graph. You don't have to keep plotting points over and over and over again. So f of x equals a times the absolute value of x minus h plus k. Now here's the important thing. hk is the vertex. So whatever number you have here, if that's -4, then +4 would be the h. So you always take the opposite of whatever number that is. All right? And then positive k will always be positive k. So whatever number you have in for k will remain the same. A is your vertical stretch factor. So whatever number this is tells you what it's stretched by. And then a and -a are the slopes of the rays. So whatever number you have right here is also the slope. So we're going to talk about that some more. So let's do a check for understanding. So what type of transformation takes the graph of f of x equals absolute value of x to the graph of g of x equals 3.5 times x? Well, what I did here was I multiplied that function on the outside of the absolute value symbol, so that means it's a vertical stretch by a factor of 3.5. Okay, I'm running short on time here, so I gotta make sure I hurry up. So graphing using transformations, use your knowledge of transformations in the graph of the parent function to graph this guy. So let's first of all, so what are the transformations? So +3 is 3 to the left, and then -1 is 1 down. Where's the new vertex? Well, if the old vertex was at 0, 0, and I went 3 left and 1 down, my new vertex is at -3, -1. So -3, -1. Okay? And then the slope, if there's no number there, it's a 1, so the slopes are 1. So this goes up 1 over 1, up 1 over 1, up 1 over 1. I'm trying my best to draw a slope of 1, and then -1. So that just goes through the corners of each little thing. Oops. Sorry. Let's try that one more time. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. There we go. And there's our graph. And like I said, you can come to the help session if you need extra help too. So which is the answer to the graph of f of x equals x minus 1 plus 3? Well, our vertex here is at +1, +3, and this is not negative, so it still opens up like a V. So obviously A is out. So let's find the vertex. 1, 3, not 1, 3, so B is the correct answer. There's our graph right there. Okay, so if I multiply the function by -1, it changes into a reflection. So here's our regular absolute value. Here's our negative absolute value. So instead of going up like a V, it goes down like a mountain. Okay, so valley, mountain. So the graph of g of x is obtained by reflecting the graph 3 times absolute value of x over the x-axis, which is the equation. So when I want to reflect it, I multiply the whole thing by a negative. So this is what we're looking for. We're looking for a negative out front. So B is our correct answer. Everything else, this is a horizontal shift, vertical shift, horizontal shift. This is the only one where I have multiplying for reflecting, and that's right there. So I'm almost out of time. So your next steps are to go through all parts of the lesson 4.10 if you haven't already. Take the quiz when you feel ready. Come to the help session tomorrow if you need help. Have a great day.